Are you ready to unlock the true potential of your body and mind? Introducing Analemma Coherent Water, a revolutionary new way to improve your health and well-being. Analemma has been clinically proven to significantly increase ATP levels. These are the mitochondrial energy of your body. It significantly improves your gut health by improving the state of your microbiome and provides up to 12 years of biological age rejuvenation within 3 months of drinking this water. Imagine having more energy, a healthier gut, a clearer mind, and a youthful body. With Analemma water, it all stops being a dream. Take the first step towards unlocking your true potential. Try Analemma water and revolutionize your life. Visit coherent-water.com. Every purchase comes with a 100% money-back guarantee. You can literally taste the difference risk-free. Go to coherent-water.com. Don't forget to put in the code GENIUS10 to get some money off. Join the water revolution. Again, go to coherent-water.com and put in the code GENIUS10 for a discount. Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes. And as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems, because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions, common sense, common knowledge, or Google. How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5% go above and beyond. They become very good at what they do, but only 0.1% are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Robert Twilley. He's a professor, the vice president for the Office of Research and Economic Development at Louisiana State University. And we're going to talk about what's called global bluecarbon estimates of mangroves and the role of nature the role of nature in climate change. So, Robert, thank you for coming.
My pleasure. Thank you very much for the invitation.
Tell me a brief background on yourself and then how you got to study the area that you're in right now.
Yeah, well, I did my master's degree at East Carolina University in Eastern North Carolina, and that's where, with Mark Brinson, I really got into wetlands. And we had a really interesting study on the Chowan River, and that led to a PhD opportunity at the University of Florida, where I really had the pleasure of working with some great ecologists, and Ariel Lugo was my advisor, where I started working on mangroves. And then I was a participant in the systems ecology program that H.T. Odom had set up there, where, we were thinking through the idea of ecological engineering. It was just a fabulous time to be in Gainesville. And my mangrove work was on carbon. I like to say that I did a carbon budget of mangroves in South Florida before carbon was blue. And so, but at that time, it was to analyze carbon because of the significance of mangroves to food web. We were trying to identify exactly how much carbon flux out of the mangroves contributed to the food webs, the fisheries in the region.
Well, what did that mean, blue? I mean, what do these colors have to do with it?
Well, it's the blue carbon. When carbon turned blue is this idea of how ecosystems on the surface of the earth could mitigate the CO2 increase that had been pretty well established with measurements out in Hawaii, that we were seeing a very significant increase in CO2 concentrations in the atmosphere as a result of fossil fuel and cement and et cetera. And so that anthropogenic CO2 signal in the atmosphere, there were questions, well, how does nature, what's the role of nature on, to sequester that carbon dioxide and store it permanently? When I say permanently, a 100-year life cycle. And blue was specifically looking at coastal ecosystem and the ocean. what's the role of those ecosystems in contributing to or possibly contributing to mitigating the CO2 increase in the atmosphere? What was interesting, I'll tell you a quick little story. In 1992, or actually it was around 1990, that my paper was published in 1992, around 1990, 1991, I attended a conference in Bad Harzburg, Germany, where was all the major carbon researchers on all the major biomes around the world. We met in Germany to construct one of the first global carbon budgets of ecosystems. And the significance of that meeting, again, was prompted by the fact that we're seeing a CO2 increase in the atmosphere, and wanted to make sure that, conservation of these ecosystems were very important because they contributed to this carbon sequestration and carbon storage process. And my job was to develop budgets of wetlands and globally, but specifically I wrote a paper in a book that was published in 1992 as a result of that conference on the first global carbon budget of mangroves. And in that paper, we actually estimated how much carbon mangroves globally were sequestering in soil and in the wood. And so that's the sort of the first benchmark, and published in 1992, of a global carbon budget for mangroves.
What does that mean, a carbon budget? Whose budget is it? What do you mean?
Yeah, well, it's when I say budget, it's pretty much like your checkbook. You budget out what your earnings and you budget out your costs, and your wealth is pretty much what you've got left. We do the same thing when we do budgets of carbon, say for mangrove. We add up all the carbon that's going into, when I say into a mangrove ecosystem, a lot of that's by photosynthesis. So when you see the green canopy of a tree every day, CO2 is being absorbed from the atmosphere by the leaves of the tree and stored in wood, and some of that carbon, and each year that tree trunk increases in diameter. So there's every year an annual increment increase in carbon dioxide that gets stored in wood. And then some of that carbon ends up moving from the leaves and the canopy down into the roots. That builds what we call the soil organic carbon, which is, and each year there's an increment increase that carbon. And so then you have to calculate how much carbon you lose by respiration. One of the big factors is how much carbon do you lose by export, because the tides come in, they pick up some of that carbon, they take it out into the estuary. So you add up all the inputs, you add up all the outputs, and what's left is your net ecosystem production, or what I will describe as the net carbon sequestration. And again, just like your checkbook, as I define the wealth is the difference between what you make and what you spend. A carbon budget of mangroves is the difference between the carbon input and the carbon output. That difference is how much is stored or sequestered each year in a mangrove forest.
Oh, so what's is there a metric, like each mangrove tree sequesters X amount, or, what did you find?
Yeah, that's a really good question, because that has been, I think, one of the our lab over the years has improved the budgets, because when we first started, there's two major measurements that we use to estimate the total carbon storage or carbon sequestration in mangroves around the world. One is, just like I talked about, the increment of wood growth, right? You got to know, all right, how much does the mangrove tree add to the wood, or how much is the increase in the diameter of an average tree and an average forest globally. And that's one of your metrics of carbon sequestration. And basically in 1990, or in the paper in 1992, we only had 15 measurements globally. So we took those 15 measurements and extrapolated it to what it would mean on a global basis. The second measurement is, how much does the soil increase in elevation? That's the increment that is the amount of carbon it stores each year. And believe it or not, soils in mangroves, they increase, 2 to 3 millimeters, or let's say, a tenth of an inch every year. And that increases an increase in carbon that gets stored in those mangrove soils. Again, a lot of that increases because they're pumping carbon down into the roots, and that is what's building that soil. And we only have probably 20.
Compare a mangrove tree to another tree. That's totally different.
They're totally different. And the density, it's really important that.
Why would they take measurements from other trees and average this or that? I mean, who knows even what the average is? Like, can you tell, like, again, how much, based on the circumference of a mango tree and the height and the foliage, how much it would sequester or no?
Yeah, you can. That's exactly right. And so we would calibrate what a certain size tree. In fact, we even did it by what we call size class. We took the measurements that we had globally, we put them in different size classes of trees, and then we took global statistics of what the size classes of trees look like across in different regions, and that's exactly how we took a few measurements and extrapolated it to what the total carbon storage is in a tree. Did the same thing with soils. We knew we had 25 or 30 measurements of soils. We knew exactly what the growth rate was in those soils, and we came up with an average of 200 grams of carbon per meter square per year of soil carbon storage. And then we just took the area of mangroves globally, and that gave us a number for the total soil carbon storage for mangroves. So thus we came up with a number relative to the total carbon, which was 56 teragrams of carbon per year. That was the global measurement of mangrove carbon sequestration.
Are you ready to unlock the true potential of your body and mind? Introducing Analemma Coherent Water, a revolutionary new way to improve your health and well-being. Analemma has been clinically proven to significantly increase ATP levels. These are the mitochondrial energy of your body. It significantly improves your gut health by improving the state of your microbiome and provides up to 12 years of biological age rejuvenation within 3 months of drinking this water. Imagine having more energy, a healthier gut, a clearer mind, and a youthful body. With Analemma water, it all stops being a dream. Take the first step towards unlocking your true potential. Try Analemma water and revolutionize your life. Visit coherent-water.com. Every purchase comes with a 100% money-back guarantee. You can literally taste the difference risk-free. Go to coherent-water.com. Don't forget to put in the code GENIUS10 to get some money off. Join the water revolution. Again, go to coherent-water.com and put in the code GENIUS10 for a discount. So what is the idea here? Is that X amount of mangroves have been, if an area had particularly high outputs of carbon, or like what's the goal of this?
Yeah, so two things. One is we also look at the total carbon that's stored in the soils and in the trees. And two perspectives here. One is you want to conserve the mangroves you have because they are contributing to removing CO2 from the atmosphere at a rate of 73 teragrams per year of CO2. Now that number has changed, and I can talk about that in a second. That number's gone up with our most recent analysis. But the other part of why carbon in mangroves is important is because besides the fact that they remove a certain amount of carbon per year, and you want to preserve those mangroves because they're helping you clean the air, right? They're every day free of charge. They don't charge us to do this. They remove 73 teragrams of carbon per year and help clean the atmosphere. Now, the second part of the story is these are also the soils and the wood. Mangroves are big storages of carbon. They have a lot of carbon in all those trees and a lot of carbon in the organic matrix of those soils. And if you go in and damage a mangrove forest, if you build a shrimp pond and you cut down and you burn all those trees and you dig up all that soil and that carbon gets exposed back to the atmosphere, well, now you're not removing carbon from the atmosphere. You're actually now contributing, just as you do with fossil fuels, to the carbon CO2 increase in the atmosphere. So the key here is that we, keep these landscapes intact so that they provide the service of cleaning air and not destroying them because you're releasing these huge storages of carbon that end up back into the atmosphere and contributing to climate change.
Okay, that makes sense. Well, mangroves in particular, where can they be put and where can't they be put? I believe they're in swamps, right?
Right. These are wet land. There's a reason we call them wetlands. The soils are wet for a large part of the year. And for mangroves, they're also, adapted to salt. So wherever you have water that's flooding these lands for a large part of the year, and that water has salt, that's where you'll find mangrove. So they're on coastal shorelines around the world. Oh, a third dimension, third very important that I should have mentioned, is that they are not resistant to frost. So they're found in tropical and subtropical and also warm temperate regions. We have them here in Louisiana. And because our frequency of frost has been decreasing, so our mangroves have been expanding. So you find them in these warmer climates along the coast where you find water inundating land that has salt. That's the mangrove area, about 160,000 square kilometers of mangroves globally.
What other candidates would you use, though, in, if you're not in a wetlands and you want to restore the carbon balance there? Are you and other scientists identifying, like, okay, depending on the area, the geography, et cetera, the non-invasiveness of the plants, you don't want to put the wrong ones in.
Right.
Is anyone building up a library of, natural ways and natural plants and other, creatures to restore carbon balance in places that need it?
Yeah, you bet. There's a whole industry, if you will, that is, concentrated on carbon sequestration and one of the ecosystems globally, again, that's most effective in carbon sequestration are wetlands. And whether they're freshwater or saltwater, the soils and the plants in wetland areas are very intense areas of carbon sequestration. And we have now, ideas of nature-based solutions, ecological engineering with nature, this whole idea of engineering landscapes to form wetlands, to expand wetland areas and provide this ecosystem service that these ecosystems provide that store carbon. And so I call it ecosystem design, because you're designing landscapes with the purpose of actually enhancing the carbon sequestration potential, and they're contributing how nature can help clean the air and the atmosphere.
Very interesting. Okay.
And it's a whole industry. I mean, you've got engineering firms and mitigation banking where, you want to expand a parking lot or a mall in one area and you mitigate that by building and expanding wetlands in another area. That's one major industry that's developed. And then you have major, incentives relative to farmland to reduce flooding. And these farmlands are being, restored back to some of their natural wetland landscapes. And that reduces nutrient runoff from agricultural lands. It also enhances carbon storage. So, it's really interesting to see these industries that are, developing, and a large part of it is because of this awareness, which you can start to monetize, that these ecosystems are help cleaning our air. And it really is quite fascinating just in the last 10 years how these industries have expanded.
Well, very good. What's the best place for people to find out more about your work?
Yeah, so at LSU, we have, our lab has a website. Actually, our Twilley at lsu.edu is one of the easiest ways to get in touch with our work. And again, by the Department of Oceanography and Coastal Science at LSU, go to that website, and there's actually myself and several other scientists who are all working on this blue carbon, enterprise, if you will, and how wetlands contribute to that around the world. So I appreciate the time and very much to share some of this experience with you.
Well, very good, Robert. Thanks so much for coming on the podcast. I appreciate it.
My pleasure. Thank you.
Are you ready to unlock the true potential of your body and mind? Introducing Analemma Coherent Water, a revolutionary new way to improve your health and well-being. Analemma has been clinically proven to significantly increase ATP levels. These are the mitochondrial energy of your body. It significantly improves your gut health by improving the state of your microbiome and provides up to 12 years of biological age rejuvenation within 3 months of drinking this water. Imagine having more energy, a healthier gut, a clearer mind, and a youthful body. With Analemma water, it all stops being a dream. Take the first step towards unlocking your true potential. Try Analemma water and revolutionize your life. Visit coherent-water.com. Every purchase comes with a 100% money-back guarantee. You can literally taste the difference risk-free. Go to coherent-water.com. Don't forget to put in the code GENIUS10 to get some money off. Join the water revolution. Again, go to coherent-water.com and put in the code GENIUS10 for a discount.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.